All right. Good evening, everyone. First of all, thanks for joining us. Can't believe it's another month. Time flies so quickly. Yeah, this is our number 60 meetup in Australia. Okay. Welcome. Find a seat.
Do you want to turn the lights a little?
Yeah, maybe a little bit.
Maybe late? Yeah, that's probably too dark.
Yeah.
We are living in the cave.
All right. If you guys haven't scanned the QR code yet, feel free to follow me, follow our social pages. And yeah, we are pretty popular. Yeah, if you look at the numbers, you can see we have quite a lot of followers. They all join us to learn, to share what we learn, and helping lift each other. So a little bit of myself. I know a lot of people probably already seen this. Yeah, I don't want to repeat that again every month. Yeah, I just love AWS. Okay, and I love other cloud as well. Okay, I love Kubernetes. So yeah, keep doing all the learning certifications. Yeah, just trying to inspire more people to join. And this is what I did. Complete all different certifications. Now there is a big trend. What do you guys see? So I used to do the cloud, do the Kubernetes, and now more people are doing the AI learning. I keep sharing all the learning certification in this kind of code, but I guess probably a lot of people still miss it. Did you guys know 50% of the media? Probably it's the hottest certification right now. The last 2 days, you can use the code find from our website to save 50% to do the immediate loading, but also some other loading certification, like if you still do the Kubernetes, 40% off all the bundles, okay? And plus something else. Did you guys notice when you spin up a GPU cluster, it will cost you a lot of money, right? That's where the FinOps, I also see a lot of people think about the FinOps in the enterprise companies, need someone specialized on the FinOps. So I also managed to working with the FinOps Foundation to get us 20% off for FinOps certification. Okay. All of these
Anything in AWS?
Or if you want to do AWS, they don't support our community. But we so most of these guys are actually don't support us. So example like for AWS or any other cloud, you can easily find a 50% of the discount. Where? So join our Discord. The people willing to share their own 50% of the discount code. So example like I passed one AWS certification, you can get a 50% of voucher. Actually, you can't believe it. A lot of people actually waste it. They are not using them. So why not donate to us to help other people? So there are a lot of people actually donate to us to help the rest.
I did last one.
Okay, yeah. That's
especially for another one.
Yeah. So pretty much our community is trying to build an environment for people to help each other. So if you donate to us, we will help someone else. That's it. And sometimes people also donate us free modules. And we can help more people to on their journey more affordable. Basically, you don't have to pay. We actually feature the guys that donate us free vouchers as a community hero. Okay. Yeah, just to create an environment to encourage more people to do the same thing, help other people. So I keep talking about we are running the largest cluster. Yeah, we beat the Amazon. Amazon don't have any cluster running 200,000 nodes. So we do have 200,000 plus members part of our community. Okay, so feel free to join our Discord. You can find 50% of the code for English, any form of it. And sometimes free exam modules as well. Scan the QR code, you can share the photos. Okay, you can download the photos as well. I encourage our members to help us to spread the news, do the LinkedIn posts, so more people know us. And hopefully we can find more sponsors to support us. And some of them actually donate us with free in the modules. So it can be Kubernetes, it can be GitOps, for example. And I haven't got any contact from like Claude Code or yeah, we can find some more credits for our members as well. But that's a tough problem. I haven't found anyone yet. So tonight we're gonna really some awesome talks and from our amazing speakers. The first one we got Frank. Yeah, first of all, yeah, let's give him a round of applause. Without the client support, we want to have a place like this to do the loaning certificate, to do the sharing, etc. Yeah, give me a few seconds. Our second speaker, yeah, she is a awesome speaker. She is a public speaker, did some sessions at multiple conferences. I met her at some of the events. I asked her, can you join us? Yeah, she willing to join us to do some real world experience sharing. Came for the Kubernetes, then realized, oh, the AI did the Kubernetes. Do we really need us? Interesting thing, yeah. Let's see, yeah, Olga from Ping Identity. The last topic, yeah, also I joined some other events. I met Ava. She did a very good talk last time when I joined the event, and she happy to join us to the sharing from 0 to episode 1, building a content pipeline with Claude Code. Anyone not using Claude Code? No? Everyone using? Wow, that's amazing. Yeah. Last but not least, we're going to have a quiz time. We will do the group photos. Yeah, I hope you guys don't mind. Yeah, we take a group photo, we do LinkedIn post to hopefully we grow our community. I find more sponsors to support us. So our mission, yeah, I keep talking about this. Yeah, I know a lot of people really know this. We're just trying to help people empower the community to learn faster, to get certified smarter, to grow stronger. Some of the community program we created, one is called AWS or astronaut. So if you are fully certified on AWS, we will feature you on our global map. And we also have a multi-cloud program. It's called kubestrong. And what else? Yeah, we need more of you guys to be here. We need more volunteers, especially from the next 2 months. I'm actually overseas. So we need more volunteers to join us. Right now, we don't really have any volunteers. We used to have a lot of
You had a
volunteers.
big list, isn't it?
Yeah, but now, only Rashendra here. Louisa is helping in the background for us, for our recording.
Projects.
Yeah. So we need more volunteers. If you are willing to contribute your time to helping, I know Gautam, he just want to express his interest, want to join us. So we need more of you guys. Yeah. We need more volunteers. So we have if you visit the website, you go to the link tree, you can find one of the link is volunteer. Yeah. So without volunteer, we won't be able to do anything. Okay. Our sponsor, I already mentioned that AWS is one of our long-term sponsors to provide us the space for us to learn from each other. And we do have a pact. Yeah, I do have a book from a pact. Also, Exam Pro, they also provide us with some loaning purely for AWS, but they do also have the loaning for some other platform. So this is what I normally keeps talking about. Stop paying full price or never pay full price. So I built the platform, the web page, just to highlight all the loaning, all the events. So one of these, like FinOps, some of the global events, we don't have any events listed here local. Yeah, I just needed the people are willing to support us. They gave us some special discount codes for people to join the events. You don't have to pay full price. 2 days, only last 2 days. If you want to become a KubeSmart, so the bundle 40% off. This is a one media. Actually, where is Tiago? He shared us. I tried to talk to them, but I could not find any discount. And Tiago joined one of their webinar. So got this discount code. And it expires on 7th. Okay. If you want to do any immediate certification, use the code. You can save 50%. Why not? Okay. And the FinOps, all of the FinOps certification, you can get 20% off. It's better. I know it's not a very high discount, but better than nothing. And this is the one Exam Pro. They supporting us, all of our members. You can use the 60% for discount code. Literally, all of the different loans, not just AWS. For the free one, they provide us for AWS. Okay, and yeah, tonight we do have some freebies giveaway. Some of these are my own collection. So like the t-shirt only M size, okay, because it's my own collection. Yeah, no other size. And also, yeah, recently I collected some really good. Yeah, I don't know if you guys can see. I got some really nice stickers, limited edition. Yeah, you don't see many, Claude code. Yeah. I don't know if you guys can see. Yeah, that is okay. So what I need is you guys need to follow our LinkedIn page. Okay. React help us spread the news. Okay. And then you can collect the stickers. Yeah, I can get you that. And we also have the books. Is that cracking the? Yeah, that's the one. Cracking the Kubernetes. So it's a pretty good book. And we do have a 50%, 100% of Claude exam modules. But that one you need to join our Discord, okay? And so the idea is that people donate to us, and we help you. If nobody donate, we can't help you. I don't know, or maybe some company donate to us, so we can help you before. Yeah, that's about it. I forgot to mention the Hero Club. Has anyone heard of this program? So basically, anyone actively supporting us, React repost like our LinkedIn page, we feature you guys. Also, if you donate the free exam modules, we feature you as a community hero. Yeah, that's part of my introduction. So we're going to start our first talk from Frank. So he will do some real-world experience sharing how to leverage the 𝐒𝐾𝐑 hybrid node. Did you also buy he also bought the NVIDIA DGX Spark, right? Yeah. So that's a very interesting topic, how to run 𝐒𝐾𝐑 hybrid. Okay. Yeah, let's give him a round of applause. Let's welcome Frank. Yeah.
There you go.
Can you unmute?
Probably I have to use a voice here, so I cannot move around. All right, cool. Thanks everyone. My name is Frank Fan. I'm a solution architect from AWS. My colleague Shane Chen built this solution. He won't be here today, but he will co-present with me in the future events. So we talk about unlock GenAI inference anywhere. Before we talk about technology, let's meet our friends. John. Basically, John is an operating manager working for a logistics company. He is a manager managing 50 sites, warehouses. But very often, something happened, keep him wake up during midnight. Just the last quarter, there's one safety issue went undetected for 40 minutes. Nobody noticed that because it purely rely on a person, single person, watch a bank or CCTV screen. That's all it have. He really need a real-time alert system to detect any potential risks and proactively so alert his team, because the warehouse have very heavy machinery, forklifts, and some hazardous goods and people moving around. He really need to have this result very fast as possible. But one challenge also, this warehouse, they have some compliance regulation requirement. All the data cannot leave the premise. So what can he do? So basically, this is not just a single challenge for this single company. We observe a common challenge across the industry. So AI infrastructure become a strategic constraint because it's not all about when I'm going to use AI. It's question about, do I have a capacity reserved for AI? And data sovereignty and regulation requirement become also a requirement. People need to, like in John's scenario, data cannot leave the warehouse. And in some area or use cases, basically, like regional side, you don't have very solid network connection to the cloud. So it becomes interesting how you're going to run that workload on premises without very, very consistent network connection. Last but not least, I'm very fascinated about some latest use cases like automobile, autonomous vehicle, or robotics. For example, in some cases, you really needed a millisecond response time, right? The robotic need to move straight away to take action. So these are all the common challenges. We observe this challenge really need answer. So here we go, hybrid AI. I will discuss what hybrid AI is and also how to deploy the hybrid AI on EKS hybrid nodes. We are here for Kubernetes Meetup. We'll follow his demos and also resources you can follow up. That's enough talking. Let's go straight in how we can make this happen. Let's make it practical. All right, this solution we built called Safety Lens. Basically, this is a solution we take the camera feed as input. So at this stage, I just use the pictures as a demo. So these are 3 pictures, and we have agent built in. This is not just reactive, it's proactive as well. You can have a conversation with this agent to figure out, hey, what's happening at the moment? Which scenario I need my immediate attention? Because we use visual language model to detect the risk and come up with a score and also traffic lights. If it's red, it's critical, it really needs immediate attention. We also give you the details why, what's happening there. So as you can see, the camera 1 got some spill chemical hazard. Beyond that, because John's team had an issue before with forklift last week, he really understand, okay, what's happening with forklift, where it is. And then you can ask the specific question about this. This forklift in the main aisle, it stayed there for quite a long time. You really need to take some action before something happened. What if, this is just an example for pictures, what if you have a streaming coming, right, real time? Let's load that video. You will see the video basically just simulate the real-time streaming coming. You can see the right corner, you have scores, and left-hand side and bottom, it'll come up with labeling, right? The visual language model will detect what's happening and then come up with a score based on some logic. And then here you go, it's 15. It's a very dangerous situation that have some chemical stuff spilled on the ground. And when the scene changed, because you have a camera feeding everywhere, right? Multiple. When you come in this one, we need to change the score because it's not very dangerous, but it's just some potential risk because that forklift just sit in the middle of the aisle, block that lane. So basically, this solution gave John's team the real-time inference. It meets his requirement because you need to very fast to detect what's happening and also alert team. We can call out, use whatever communication channel to make his team aware. That's a solution. This is a quite a simple application with simple architecture. I will show you what's core components here. Basically, you have infrastructure, right? Need to support 3 key components. You have application, that's application as a user interface, take user input and show you what's happening. You have AI inference, that's a core part. Also, you have dashboard, not just dashboard about what's happening in the warehouse, but a dashboard about your underlying infrastructure and also application. So this video analysis pipeline, quite straightforward. You have feed coming, and we do the frame sampling every 2 seconds. And VLM, that's a multimodal model, visual language model to do the inference in the real time, and then come up with a safety score. Then we come up with dashboard to tell John's team to take action, or dashboard to tell the operator of this whole solution to take action to maintain this whole software stack and backend infrastructure. What's hybrid AI? Hybrid AI is integrating AI workloads across cloud, on-premises, and edge. But this is a very new pattern. It's grown very strongly. Just recently, Canva released a case study. They leverage this hybrid approach, have a significant cost saving for their environment. It still come up with 3 things people need to consider to adopt this pattern. The first one is orchestration. In John's situation, it's not just one solution. He has many, many other solutions running in the cloud. It's come up with the question where you are going to distribute the workload, in the edge or in the cloud, and how can make it as easy as possible and streamlined without too much human intervention. Integration is a key part. John's team already used Kubernetes in the cloud, all the toolings, mechanisms, runbooks, and people have that familiar with that, the technology, how you can incorporate that with this new use case. And performance is key. As mentioned, some situation you really need a milliseconds responding time. So inference in real time will become a thing is non-negotiable. All right, let's dive deep. How we're going to address all these challenges one by one. Let's start with the first one, orchestration, by having an automated pipeline. What does that mean? Before we talk about technology, I want to introduce one of my favorite books, Thinking Fast and Slow by Daniel Kahneman. He is also the winner for Nobel Prize. How humans think. That's a big question. In his book, he introduced system 1. It's fast, it's unconscious. For example, if a ball is about to hit you, are you going to think? No. Either you grab ball or you move around. But when you do the math or you do some financial planning for your future, you really need that deep reasoning, right? System 2, slow, conscious, you need to make effort. So that's exactly the principle we are going to adopt for hybrid AI. On the left-hand side, that's your system 1. It's running at the edge because you have lots of sensors, robotics moving around. You need a milliseconds inference, really fast action here. On the right-hand side, you perhaps need reasoning models, have deep thinking, continuous learning, fine-tuning models. And also you can have a centralized observability over there. The context, basically, it could come from user input. In this case, John's team will talk with robot interactively, that's user input. And in some cases, you have some sensors in your warehouses to capture temperature, all these images. All these things, environment data, or even robot states come in this context. But here, depends on use cases. You need to decide, okay, this request coming, should I route to my cloud for deep reasoning, or should I just route to the robot to my edge, have a very fast action and local inference over there? How is this automated pipeline look like? From cloud side, for example, if you have different streams coming to ingest the data. And then for the model over there, it's not just once-off. People probably already familiar with some use cases like robotic training. You have some pre-trained model, but in most of cases, you need to collect some data sets on the spot and feed that data set in. You can continue fine-tuning with the new data to make that a general model more accurate for your use cases. You need to register data or model somewhere and leverage CI/CD pipeline to automate this process to synchronize your model to the edge. In John's situation, he really needs a centralized monitoring because of 50 sites. He cannot just reinvent the wheel everywhere. Centralized monitoring makes perfect sense. All right, right-hand side, edge. So you have model over there. You run model locally because we really need that fast response time. So we do the local inference. And EKS, we have EKS hybrid. You can leverage a single similar technology and control plane in the cloud to provision your compute at the edge. Also, health monitoring at the edge side to capture some environmental data and also local compute information. You have application workload running at edge, which makes sense because in a John situation. All right, let's move on to, so we have this automated pipeline. But the question is, John's situation is the team already familiar with Kubernetes environment in the cloud, right? Now they introduce a new use case. Do you think you just need to rip off what they already have because it's a new use case? Of course not. They want to have consistent experience. So what that mean? They want to have reliable, secure, or high-performance infrastructure as a similar as a cloud, operational consistency, the same runbooks, processes, and same service APIs. So for developer, you don't have to change. It doesn't matter where your compute is. Same tooling or automation. Most importantly, same pace of innovation because all the good things happening in the cloud, you can also leverage this ecosystem, make it simply integrated with your local compute. EKS hybrid node was introduced over the year. Basically, how it works is if you have a local compute on premises on edge, you can leverage that compute, protect the investment you already have, and add that local compute to the control plane in the cloud, but use the same control plane in the cloud to manage these nodes in the edge or the instances in the cloud, the same control plane. The good thing is you can also synchronize all the states from your local, from on-premises to the cloud, so they know exactly what's happening there. And this is the benefit you can leverage the beauty of the both. Give you flexibility to run your workload pretty much anywhere. You still have some requirement for networking I will discuss later, but it's most of the time is you don't have to have a connection all the time. In some situation, our customer, they happen to have a disconnected network for 7 days, but when the network restored, everything back to normal. But even you have network disconnection between your edge and the cloud, your workload continue working, right? The only things rely on the cloud control plane is if you need to provision new nodes, provision a new ports, something change you need to make. But the workload continue working even without connectivity to the cloud. All right, how exactly it works? Step one, as operator, you use the same APIs, create a cluster, or you can update your existing cluster, right? You can have a mixed cluster, have a hybrid nodes. You have nodes in the cloud and also add nodes from on-premises. Step two, you need to have a side-to-side VPN or direct connect your rich the on-premise network. Yeah, because you need to route the traffic back to the cloud to talk to the control plane over there. Now you need to permission, right? Good thing is we have I rely on IAM roles anywhere or system manager to give you the roles. This permission will be required in step 4. With that permission, you you can use this hybrid node CLI to add your nodes on premises with that permission add to the cluster, so you're part of the family. As this mentioned, support all the variety or wide range of variety of the operating systems, support VMs or bare metal hardware. All right, this is a demo architecture. So left-hand side, this is a AWS environment. If someone can close the door, please. Thank you so much. So this is a left-hand side, the AWS environment. We have EKS up running there. So this is the environment you continue using, right? Because many other workloads are using cloud. And then this environment can also do the training and fine-tuning for the models. And also we have this monitoring AWS managed promises, and Grafana is used for observability. We mentioned about the centralized observability solution in the cloud. So you don't have to do this all the 50 sites. That's the exciting part. On the right-hand side, you have this shiny box. NVIDIA DGX is powerful enough with 128 VRAM and also support the latest architecture for GPU. And also we use, from software side, we leverage VLM, which is an inference engine, make it very efficient to use your memory. Yeah, this all the local inference happening locally in the Spark, including all the applications I mentioned, the user interface running over there. And now you set up the VPN, connect these two things, and everything will work beautifully. All right, so this is another thing I need to mention about the consistent experience is about how you're going to monitor. The good thing is NVIDIA always come up with a library of the tooling. DCGM is one of them. When you install the NVIDIA operator, it's one of the tools already there to capture the GPU temperature, the GPU utilization. And then the good thing is you have a centralized Prometheus environment, right? You can do the scrape the metrics from local environment to the centralized Prometheus, and then expose this endpoint to Grafana. So you see the beautiful dashboard about what's happening in your about your GPU compute. We talked about the two challenges, right? Orchestration. We talked about the consistent experience, but the last one is crucial for the success or not, real-time inference. Why is it crucial? Because in these use cases, think about it this way. You have streaming video or streaming coming in real time, and then you do the analysis. If you not fast enough, you may find out the thing already changed, but the labeling of score left behind. It doesn't make sense, right? We need to in sync. What's happening in a video, you need to do the analysis straight away within 2 seconds. Even because I think 2 seconds is a solution, need 2 seconds, but how we translate that requirement to the model inference is even harder because you have other overhead about the latency. Now we need to make a decision what model we are going to choose, right? First question is what type of model, right? There are so many on the right-hand side, yeah? And what's the size? So first of all, we choose the vision text model, visual language model. So you can use one model to recognize both. We need that low latency. So we calculate how fast we can generate token. So roughly, if it's more than 50 tokens per second, we can meet that requirement to come back the analysis straight away. And then we need to do a balance. Sometimes if you choose some very big models, it's accurate, but it's slow. We need to find a sweet spot. So here is some optimization. We select this OpenAI compatible API. Basically, you don't need to change if you swap the model in the back end. Between the dense model and the mixture of expert model, the difference is the dense model, basically, if the weight is 30 gig, it's there, activated all the time. But the beauty for the mixture of expert model, you have lots of the experts is particularly have domain knowledge. So this expert will be activated only when it needed. So only a subset the data got activated at a time, which means you better leverage memory. And between the instruct and reasoning, they'll have pros and cons. In this case, we choose instruct model. You don't need to deep thinking to kill or burn lots of tokens, but make a direct inference. Hey, that's a winner. Penguin 3, visual language models, 30B, that's a full size of the weight. But A3B, which means it's activate 3B at a time. So which is you have benefit of both. It's accurate. You have the knowledge about worth of the 30B billion parameters, but you can go very fast because only 3B parameters activated at a time. Performance tuning, we already mentioned how to do that, choose a model. The quantization is another method to make it more efficient. This is the process about the inference, right? The first step, you do the prefill, it's very computer bound, and then you generate first token, and then you save some learning in the KV cache. And from there, remaining tokens will generated. It's heavily rely on your GPU power. So how fast you can get this? Remember the magic number we come up in earlier, 50 tokens per second. That's based on our analysis about how quick response could be. What that means is, it means how quickly you can load this wisdom from the model, right? Through this memory, through the GPU VRAM. So this is a very simple calculation to come up with your tokens. Memory bandwidth is fixed if you are determining your hardware, right? Model size is up to you how you can fine tune. You can choose different size model, but you can also do the quantization. All right, how we do quantization is we try different method. We try FP8 start with, it's okay, give me 50 tokens per second. We continue on with INT4, but even further, we leverage the best practice from NVIDIA. They have their unique approach to do a better job with NVIDIA FP4 to generate 75 tokens per second, which way more than we need. As a result, you shrink the model size accordingly. As you can see the three different outcomes. You have a smaller model size, and now as a result, you have a bigger buffer size, right? Space that KV cache can leverage because the whole 128 gig that's fixed, but you have less weight space required for the weights. You have more space. Can be used for KV cache. The beauty is for a lot of the modern architecture like DGX, Spark, they use the universal memory. So this is not just for GPU VRAM, right? Your other workload, computer memory can also use this space. It also means you can have a longer context window, which is always a good thing. And perhaps you can have more concurrent sessions. All right, let's talk about how exactly we build this solution. What's underneath technology used? So this is a typical cluster with hybrid node enabled. You can see the compute here. I enabled hybrid, this particular node, that's a DGX Spark. We already use AWS add-ons here, metric server. This node monitoring agent, very proactive way to detect the failure and do the repair and notification. From here, you can see some information about this Spark device. It's NVIDIA kernel, NVIDIA version of Ubuntu. And then all this dashboard showing some overall information. We mentioned about some applications, right? So this is a safety lens, that's application, the user interface. And this Penguin 3 thing, this is the inference server. These are two key components. We leverage VRM as inference engine, and then we do lots of the fine tuning and optimize performance. So here we pass on some parameters. We leverage this specific model. We mentioned about why we choose this model. And even further, we leverage this particular environment variables to make it better performance. Beyond that, we enable prefix caching. So in that case, all the first time you get the data cached in the KV cache. So next token generation will become a lot faster. And also here is the environment variables we pass on. And then you can, if you like, you can change the frame interval, depends on your requirement. At this stage is 2 seconds. Every 2 seconds will capture that frame. From Kubernetes side, here we installed a GPU operator, as mentioned, that come up with lots of libraries or toolings. One of them is DCGM exporter to export your GPU metrics. And here's the YAML file. You can see we have this GPU operator defined here. And then we expose basically this information to this URL, which is the Prometheus endpoint. And we go to the Prometheus. So here you can connect with Amazon managed Grafana. Then you can have a dashboard to let you know what's happening in your backend environment, what's the utilization temperature of GPU. Remember, we have 50 sites, right? So this is a very useful data for operator to understand what's happening. Yes. Here we go. We have a happy John. He don't have to stay awake all the night. Basically, as you can see, it's the same solution, right? Same environment, same experience. It's the same data, same warehouse, but he can basically leverage local inference, leverage the strengths from the cloud and edge to come up with solution which is so powerful. In the end, these are some resources related to this solution. You can scan the code. I list lots of the resources over there, including some hands-on workshops, including some solution architecture we build this solution. All right. Overall, that's all from me. Thank you. Environment with the 5G. So that's all. Question for the pricing. The 𝐒𝐾 hybrid is the same control plane as the 𝐒𝐾. So each computer plane the same thing as control plane. On top of that, because we use this control plane to manage what computer you're bringing in, we add a fee for based on CPU. You can find out that price in price calculation in AFS, but a very reasonable fee based on CPU or based on basically of your nodes. The third one about scalability. That's beauty. You have a brain in the cloud, and also you have also all the sites everywhere. You can basically connect your learning. For example, one robot, you bumping something. That's your wisdom of learn, right? But you can synchronize that to a centralized memory system in the cloud, right? People, other robots don't have the same mistakes. You share the memory across the board. So that's a way you can collect data from all the fleets and then make the reasoning model recognize that, and then you fine-tune the model and load the latest model back to the edge environment and make it smarter. Hopefully, I answer your question.
That's fantastic.
I don't want to take more time, but we can hang around during break and chat more.
Thanks, Frank. Yeah, our next speaker, she's already ready, Olga. She's so excited to share some real-world experience about AI Kubernetes. Okay, here we go. Let's give her a round of applause.
Get rid of that. Do we have to do that? I'll try about that.
All right. Thank you for introduction. I think everyone can hear me all right. So we'll go without the mic. So my name is Olga, and I'm senior staff at Certify. I work in Finger Identity, but today's talk it's not really based on any specific workplace. It's more like my generic experience, and the demo that I'll be showing is actually built on top of my own setup. And today's talk will be a bit different for me, like it's less technical, so people who know me, you can relax. And it is also different in a way that I'm not only going to be talking about the tech itself, but also about a little bit about the human in the loop, or our experiences. We all live through this AI disruption, and I think it affects all of us, affects us in different ways. And I will share a bit of how I experience it, how I feel it, how I hear other people living through that experience. And so what not to expect here. I'm not a token maxing person. I actually don't build any crazy pipelines that burn lots of tokens. I'm not saying they don't have ways. I think there's some good examples on how to build these software solutions with very robust and sophisticated workflows. So today's talk is not about this. It's more about how you gain speed in your everyday work through little improvements or through things that are more within reach than something very sophisticated frameworks or the latest tool or whatever. I also want to talk more about it, software engineer versus platform engineer, because I think we have a little bit different way of working and different way how the AI models are and the AI products generally are thinking about. Okay, I'll start a bit introducing myself a little bit more, as well as the project that I'm working on, so that you understand what is the AI workflow that I want to show you and what's the value of it. So I've been around Kubernetes for a long time. My first experience was with V110, and we had very fun incidents back then, running production on Kubernetes, and half of my pods are gone. Where are they? And we didn't have AI, didn't have much of a Stack Overflow. And when Kubernetes first rolled out, the first use case was we want to deploy applications, we want to serve our users. So your first real production use case was the Northwest. You have your end users, they go through layers of your whatever ingress layer you have, land on your Kubernetes, get to the request served, and go back. And then as years passed, more and more solutions and requirements were added to the entire ecosystem, and then multi-cluster architectures came along. And eBPF started developing, and then Cilium. Cilium at the time, there was like taking the world by the storm. Like this default CNI mainly managed, probably in every managed Kubernetes distribution so far, is probably Cilium is what powering the network, the low-level networking between your pods. So when that came around, I got really interested about this east-west between the clusters, not just within the cluster, but within the clusters. But I am a platform engineer, and I am very good at bike shedding. If you know what that is like when you get to build a nuclear reactor, but instead you spend a lot of time building the bike shed for the workers when they come. So I'm still bike shedding this. I don't have the clusters that do the multi-cluster. But why am I telling you all of this? It's in a way to explain when I'm going to talk about how AI took my Kubernetes, like what Kubernetes actually means to me, and the experience that I have before the AI rolled out. So this is my setup, and we don't need to understand all of what's going on here. We just need to understand that this is a bit complicated. There is a lot of moving parts, and there is a lot of dependencies. So you can't deploy applications before you have the workload clusters, and you can't have the workload clusters before you have the control plane. These clusters live in the cloud. That's temporary local cluster, and I have like like bootstrap sequences that run in GitHub Actions, and all of these, lots of moving parts, so lots of opportunities where things can go wrong, and they did go wrong over the lifetime of this project. This project, by the way, is something that me and my previous colleague, we demonstrated this a few times as a reference architecture on how you manage GitOps clusters with like basically decoupling the scaling of your infrastructure from the applications. Application can think in the domain of like failure domains. You can have zonal or regional or whatever, and the platform team will deploy your applications in the right way. So you have the platform separate, the application separately, and yeah, this is where this setup is serving me. Okay, so then what happened? I think this journey you all know, and you all experienced it. The chatbots, the first chats that rolled around at the end of 2021. So you start asking questions, you copy paste, here's my error, and can you please help me understand? You copy solution back to your whatever editor, YAML files. You have another error, you go back and forth, but you still understand what's going on in your estate. Then the next thing, Claude code. So Claude code, also a little bit of like I put in the description, a frog boiling in the water. The loops became longer, they became more powerful, they could solve more like comprehensive problems, and maintain the execution until something is really done, like until it's done. So it's not just I fixed that, here's your files. Yeah, but it also happened gradually. It didn't happen overnight, right? But eventually you now know less because you went one level up. So now you give it a high level task, and it goes and fixes for you. So this is where I am now. So now we have more features, skills, agents. We have the Claude harness that is sometimes like depends on the day of the week. It can go for a long time, or it can but most of the time it actually does do quite a decent job. Yeah, you can trust that it's doing like really good job. And then, but for my use cases, it was still not enough. And in all of these areas here, there was still so many places that I needed to go tweak another thing here, tweak another thing there, tweak it. Like it's going for like the good run goes for about 30 minutes, and if I need to check every time where it is stuck, I need to click here, tweak something there. It still takes my attention, but it's like really fragmented. So now I feel there's another loop that goes and babysits this for me. Because every time that I go and check something in my setup, there's actually nothing clever happens there. I need to go get kubestrong or 𝐒𝐓𝐑𝐋𝐋, and then do a decision, change something. Like it's really not something that AI can do for me. It's just this missing orchestrator on top of it. So this is what I've done. Now I have 3 people working on my setup. None of them is me, and none of them are people. So, okay, so software engineer versus platform engineer. So why do I think, I don't want to say that software engineering is solved or is it easy. I'm just saying that I feel that the platform engineering is different to software engineering. And I feel that the primary focus for frontier labs or the harnesses and all the discussions, even if you pay attention to the language that is being used, we say coding assistance. We say like coding must fault, software engineering. It's a little bit different problem space. For example, in the infrastructure, the cycle, the SDLC is a little bit different. It's not as easy to go and test. For example, if I want to make parallel branches in the setup that I just told you, or other features that we test, like what we build, the multi-region local load balancer. Yeah, so it's not that easy that you can spin up 20 load balancers. Yeah, it's different. The unit test as well, we don't have the unit test, you often don't know until you deploy. Then obviously the cost. And another thing, like, so YAML is programming language if you do need to categorize it, to put a label on it, but it's not. Think of it like, what do we change in YAML? We change settings, we change configurations, we ask for features. There's actually someone behind that YAML. We wrote a whole bunch of code. Yeah, so, and another one is that is the knowledge versus experience. LLMs know lots of stuff. They know, in this case, like I choose these two. I think many people can say these two is really complex. But knowing these two and actually running it at scale in the organization, I know like some knowledge from experience, like it can get wild. It can get really, really difficult to manage at scale. So that they know all the settings doesn't mean that they know the best design for you. So this is why we're doing sort of learning loops together. Okay, so I think I gave enough of like why. Now this is how what I built and the building blocks. So as you understand by now, like I'm very committed to Claude, but at the same time I'm also want to see like what's the competition doing and what's the framework offering. But from before I saw everyone like using Claude, no one raised their hand when they asked if you don't use Claude. So Claude first used the concept of sub-agents. Agents is a bit like overloaded word these days, so they call it sub-agent. Basically, it's a markdown file. You can also do the scripts as always, and put scripts in that. But the Claude concept of agent, it was more than just a markdown file. The way how they invoke them and execute them, it depends specifically on the Claude code itself. They create them in their fresh context. And I think they even have like the virtual machine or like the execution environment is different. But either way, the agents as they do in Claude.agents, it's not so transferable across. You can't drag and drop them to Gemini, like they can understand the wording, of course, but it's not the same content. But skills, on the other hand, it's something that code file like really fast. From the time when they first announced the skills and Claude, then just 2 months later they published this open source format, and then everyone adopted it. And if there is just one takeaway from this talk, is I really encourage everyone to think about skills and start accumulating your own personal skills, the things that you do and work every time. If you have something that you need to tell to LLM more than twice, maybe you need to create this as a skill. Skills really accumulate fast, and then they really empower you and make your workflow fast, make your own conversations faster, and like it's very low effort, high output. Okay, the other thing, so I have applied some look that orchestrates all of this together, settings and guardrails, and open Patel for observability. And we will have a look into how the Patel looks like. It's really cool. Okay, so here's so first of all, creating all of these is also an effort. It's something that you create instead of fixing your classes in this case. You spend some time understanding like how do I build these agents, how I configure them, how I do all of these things together. But it's actually when I heard this episode from some MTS from OpenAI, someone who built key people who build the OpenAI coders, they started with very weak model. They're not powerful enough. And that's what he said, like when you get to a model that can't really pull the weight, and you have to stop and actually double click into it and build the building blocks, even if it feels painful, it feels slow, but the feeling that you get out of it once it all falls in place, and you understand like this actually kind of blessing in disguise. Yeah, you didn't have out of the box experience, you build something around it, and then you get so much faster, even if you spend some time on maybe by shading in this case. But anyways, I think when I heard this, it's really clicked with me and resonated within the context of the project. So here how it looked like before the orchestrator. So all of this, just all of this errors from before on the single line. There is mainly these stages, wait between every stage, go and check what's happening, check, understand where you are, understand what's the error, where you need to tweak or fix or anything, and then that's the entire process is about 30 to 40 minutes. And now there is I just wrote AI into that process instead of me. It's simple look that goes and throws LLM at first to go understand where you are, what is the phase, is there any errors? If there are errors, try to diagnose them, fix forward, commit to the branch, wait for the reconciliation, see if you fixed. If it didn't fix, then try again. And it can try up to 3 times because they don't want it to be a reduction at some point. It needs to go one fixes something and another one reverts it. So you don't want to, when you do anything automated with the LLMs, always remember to put the limits, number of turns or tokens, or just make sure that it doesn't run away. Okay, so this is how it looks through the hotel. Now, hotel is really nice. You have now I have instrumented both my Python loop and the Claude that is being called from here, but also all my tools like Claude and Gemini CLI. They all come with hotel baked in. All that you need to do is to configure maybe 5 environment variables, so at least 2, the endpoint and the enable. Then you need an endpoint where you want to send this telemetry to. You can start local. You can send it to the local endpoint, set the observability stack locally for Grafana, from all of this CNCF stack, which is open source, and you can do it locally. So here you can see like very clearly what's really happening in that project. Yes, so you have the root span that says here we start. We have phase which is the bootstrap, the first thread, and we have the phase that's looking for the control plane. And now to provision the control plane for us in the cloud, it takes some time, so it sets timer. It says, okay, now I'm in this phase and I'm waiting for it. Wake up, let's have a look what's happening, and so on. And then until it's like the diagnosis is a step that actually looks at the class and understands is there a problem, and if there is a problem, then it is fixing the problem, and also consults the technician to understand what they're actually working on. Okay, so that was a little bit of demo that I wanted to show. Okay. Yeah, so this is a bit different way of. You can see in this case it's a simple loop. In the process itself is fully deterministic, and it is just a task. Then in parallel, you run this AI babysitter that goes, collects the states and saves the states for the later analysis if I need to look through the dumps. Phase checker that understands like what is actually our state, and then the diagnostic agent that does one of these things, either fix forward or escalates. So if it can't fix, it doesn't understand what's happening, or it did 3 attempts and it didn't work out, then it will stop. Okay, so again, this is now connected to my Grafana, and again, you can go and understand exactly what is going there. And you can even go and dive deeper into the spans to understand which exact LLM calls were done, how many LLM calls, and within LLM calls. So you can see within each phase, I actually invoke the Claude, and then it itself can invoke tools, or it can call an LLM. And from this, I can also, where's the LLM tools? LLM request, so here we go. So you can also, from metrics, or depending, like the information about tokens is also available here. That's what I'm trying to say. So you can also get, you can't improve what you can see, right? So that's all available through the telemetry, and it's just really nice once you can see and understand your process from a more high level. Okay, so that's how it works. Now, to enable it to run, to give it autonomy, we also need to have the security. Right, this is what I'm demoing is the open source, like my own project, and I use it a lot for demoing, even for my work. If I want to reproduce something in a standalone environment, or if I want to show the concept, you actually need to understand the concept. It's something that is fairly simple before you go and you see, like in real life, you can say spans of 10,000 spans in trace, like really difficult to understand. So in my case, though, that it is standalone doesn't mean that I can't do damage. It's still connected. It's on the GitHub. It's connected to my GCP, connected to my other accounts, and do the settings and what's allowed and what's not allowed.
and the guardrails. So hooks, if you don't use hooks, I really recommend doing this, because this is the deterministic and proved guaranteed way that the harness will call for you these scripts or whatever you provide there, and then you can enforce whatever guardrails and controls that you need. You also steer the model from there. So if, for example, if model try to do git push to somewhere that you are not allowed, or try to do, often this happens like move files. You don't move files, you do git move. So I can say, if you try to do git move, maybe you forgot that everything is versioned, and I say only use git move, it's all versioned. So LLM takes the hint from your errors as well. But they're also very clever. There is be aware that there is cases where LLM found the way how to break out of all of these sandboxes. It's wild, but it's better to have this than not to have this. And the last thing that I wanted to show, like, yeah, so that's the execution in. I want to move this out. So what you see here is that every agent is actually executed in its. I can't select here, but these lines where you have the log, this is execution of standalone agents. Why is that good? Is that you start, as I mentioned before, agent starts in its own fresh context, and you don't collect these long running conversations, because this is what eventually goes into your cost. And the cost, the attention. So again, in this example, this is like really small, but it's all kind of the same when you run the diagnostic loop that you do for a cluster, even like the non-production cluster at your work. Like imagine how many namespaces there, or how large the namespace is. Okay, so I want to actually finish with this project demo, and then I will say also how it does help at the workplace as well. So again, this is just to iterate like how that changed the way that I work, not just on this project, but again in my work as well. So I'm not interacting with Kubernetes with my setup, not even through Claude code, almost never. When I want to do any features, I tell the orchestrator, like, do this for me, make this happen. The loop is the same. It's not that I need to change the orchestrator, but it does. It also a piece of software that also needs its own development. Yes, the orchestrator is driven by mission. It's the setup, the workflow that it executes doesn't change. Yeah, but it does have the bugs and twists, and I still have a lot of ideas that I want to trial there, but all of the ideas now in the AI space. So Frank previously mentioned that he has a DGX Spark that is connected to the EKS as a node. I also have DGX. So that's I want this guy to run on DGX. So this is coming back to this point, is that Kubernetes is or was important for me. I'm not sure anymore, but my free time is now going in all of this AI stuff. Okay, so, and I live in these two camps together. So have you heard about Peter Steinberg and the open core? It's a wild phenomenon. It's really wild what happened, but I really recommend you to listen or watch this podcast with a pragmatic engineer who interviewed him like really early when this was still named Claude. But it gives you insight like where this person comes from, how he thinks. It's not just that he went and just white-coded this thing. There's a lot of thought about this. There's a methodology and there's a mindset, how he operates. And at some point he said, like, when he was describing how he builds it step by step, building the Telegram channel, this integration and that integration, and then you can see like his eyes light up, you know? And then he says, almost exact these words. He's talking through like the talk like the speaking language, but I need to make it more like as a sentence. So the beauty of this is that technology disappears, and you don't need to think about the computation thing like the computes, and that all that context blends away, and nothing's perfect yet, but it already feels magical. Yeah. So when the first time that my CD loop did this upgrade of crossplay, committed its changes, got conventional commit with explanation of what it did and why, and did it like over the course of I think it was about 5 commits in total. It did feel magical. I on purpose stayed away. Like even if I knew like here you need to fix that, I just stayed away and I wanted to see how it fixes itself. And then on the other hand, I have people who say like, I used to like this thing, but now like what's the point? And the funny thing is that you can feel these things at the same time, just like what I shared with you today. Okay, I want also to bring this, it's not completely theoretical exercise. These days I'm working a lot on I worked in previous role as lead engineer, now I'm senior staff SRE. So I'm working a lot on coordinating and delivering and designing large and complex deliverables. And there is a lot of theory and there's a lot of experimentation. There is a lot of stakeholder management. There is a lot of inputs that go into design. And then there is also a technical side of it. Yeah, if I don't have engineers that work for me, then I do all of this experimentation as well. And for example, in my previous job, I did design for agentic runtime platform, for CI/CD for agentic runtime platform. Everything is bleeding edge. Products got renamed. SDKs change weekly. I can't keep up with everything that happens like week by week by week. Like I really can't. I implement a pipeline that does all the good things that SDLC tells it to do, and then something changed. They renamed the product for something else. The logs now don't look the same like they looked yesterday. And this is crazy. So I started to collect all of these bits in the skills. I built something like very simple and dumb loops similar to what I showed you. But then it does all of this and it crashes through all of these bumps and the bleeding edge on its own. I guess what I'm trying to say here is more like don't wait for a perfect solution. Don't wait for AI enablement team to solve for you all the problems. Like they do solve, but they solve for, even if you have one, they will solve for main case, for the mainstream. Your work may be specific. Yeah, so my view is that even if you do tiny, small improvements in your everyday life, without waiting for the perfect framework, without understanding the perfect, or maybe there is multi-agent system that I can vibe code. Like, just do something. Yeah, just simple vibe code a Python loop. I want to do this. I want to change GitHub Actions workflow. I expect that it will deploy an agent to this platform, and I expect logs to be like that. 3 steps. Okay, so that's all that I had for you today. Feel free to connect, follow up, and again, that's my experience, and it's more like an invitation for discussion. I'm keen to learn what you are building, how you're feeling. So you can find me on LinkedIn. You can find the slide on my GitHub pages. So Olga.mir, GitHub.io. And yeah, if you have questions, feedback, or discussions, ideas.
That was a very good, awesome share. Right? pretty sure you guys have a lot of questions. I also have a lot of questions. I want to learn how to build the skills, how to have a free action agent to help me. Anyway, any
I
questions?
don't have answers.
Yeah, in this solution, just I want to know when you started first, like how many repetition you have done to get, like for example, 99% or I mean, whatever the percentage, like human in the loop you must be having after failure.
Yes. I have 1% left human in the loop, and this is to do with credentials. But it's if you're curious, it's all sitting in my like playground repo, and yeah, let me just show you this playground. I'll show you the example of this cross-plane PR. It actually was done in two. I thought that I had, okay, I have this opened here. Even with the loop itself, it does take a lot of iteration for me just to fix the loop itself. So in all of this process, which is actually second part, I said myself, like, I need to stay away from actually fixing Kubernetes itself, even if I know. I just talk to my orchestrator and they let the orchestrator do the job. And out of these, how many? 41 commits. I think these are the main commits that it came up with as the real fixes that came up from the loop itself. And it says, like, skip whatever it is. I don't even know. So skip dependency resolution. It's important for something, right? But it said, this is what I saw. This is what I think this will fix. But you can have a look. I spent quite a lot of time on this repository, and yeah, it did take a lot of time to build the loop. But I don't know where to put it. It's not a toy project. It's something that I use for my work. It's something that I use to demo things that even if I do a conference talk on something from work, I can't show the things on work. So, but I can reproduce some of the things here, and I can bring the other way around. I can show, like, this is the technology and this is how it works. And yeah, based on that, actually another thing that I wanted to show as well that I tried to do. Anyone have experience with K-agent? Okay, so K-agent is really cool. It's you can think of it as agent inside Kubernetes. The easiest way to do it, you can deploy the Helm chart, and you can just provide the pointers to LLM, and you can put the prompt in K-agent. That's like in the manifest, and you have the agent. So that's another thing that I want to wire up, that it actually sits in the cluster and it watches itself. You can have like a cross-plane expert. So it sits inside this cluster, looks at the cross-plane resources and the reasons from within, well, what's the state of it.
Thank you.
Anyone else? That's a really quick question.
So, yeah.
Yeah. Hold on one second. We want to record and also for people on.
Oh, okay. All right. Amazing talk, by the way. Thanks for that. So I just want to understand all the use cases that you talked about. How much of that is touching live environment or production at the moment, or is it more on the side of build, where you are optimizing pipelines, getting things onboard to production,
Yes.
really not touching the production environment?
Yeah, so that's it. Okay, yeah, fair question. So first of all, we don't run any AI directly in production. You can still, there's a little bit of background here from my personal experience, where I worked in banks, in financial security, FSI, financial sector industry for like 5 years, and there is regulations, as you may know. So not in production environment, not something that actually writes and pushes to the repo. So that's for now I think is still a sci-fi area. However, when you do work with your like non-production systems and the research or what I showed you before, like you have the permissions that you have permissions to. Yeah, so if you have a cluster which is like non-production and you have your experimentation there, then do it. Yeah, the example that I showed before with this design loop and the experimentation, this was against the sandbox environment where our team was building a solution for the agentic runtime, right? So I'm not seeing that for diagnostic, like, yes, for sure. As long as you can guarantee that you don't leave any PII and all of this data out of the production environment, which is also like not a trivial problem to solve, right? For example, right now I'm working in identity where we deploy identity solutions like really sensitive stuff. We deploy it on behalf of our customers. So it's not that you can like easily point LLM, even if you have the same permissions. And hey, go and solve it because you can't trust that it won't go for loads. You can write guardrails, but you don't know what in like unknown unknowns. So I think we're not being replaced like this year. Maybe the year after. But no, I haven't seen like if anyone runs this data, I want to know. But no, I don't see itself even no. Yeah. Okay.
Awesome. Thanks, Olga. Yeah, let's give her another round of applause.
Thank you.
Really important talk. Yeah, we are looking forward to have more speakers, to join us to some more real-world experiences sharing about Kubernetes AI. So our next speaker is ready, and Ava, she's going to share also some real-world experience about using Claude Code. Yeah, let's see.
That's working, right? And F11.
That's great.
Thank you. So from 0 to episode 1, this is my talking today. It is mainly, you can see that's about Claude and how to use Claude to build your own personal workflow, your personal agentic skill, to be honest. And I personally, I am not a professional of web, so I am really bad at web. So I do it all locally, and I came here to learn about other Kubernetes kind of things. But yeah, for a little bit about me, I am a founder of 𝐍𝐄𝐕𝐄𝐑. It is my personal counseling firm. So there are some people telling me that hey, you are having your own counseling and you probably should build in public. If you build in public, people will see you and then you will have more and more chances to get customers. I was like, hell yeah. And then I asked him like, where do you think I post? And they'd be like, oh, you can post some videos on YouTube. You can make some videos. And I was like, but I have no video editing skills. So I have zero experience about video editing. I am so bad at it. And then I asked him like, okay, is there any suggestion? And he's like, oh, you're all on your own. And I was like, okay, if I can build a whole pipeline just for me, just for us developers to make videos by telling it what to do, one word, one sentence, tell it our needs, and then it produce the video for us, and we can build in public, right? Then that would be fantastic. So that is why I wanted to build this workflow for myself and for us developers to make videos easily. So yeah, I have zero experience. I have no content creation experience, no social media. I don't even have a social media, and I have no video editing skill. Yeah, I wanted to ship a episode 1 to tell people what I am building. So I built this pipeline with Claude Code. And actually, before showing the pipeline, I will just show you what it looks like. This is my video. I just doxed myself literally. yeah, and I hope I believe it sounds like right. And this monkey is basically myself on the internet, and it's it's pretty natural. I can say that, and it speaks better English than I do. It even has a hiding kind of animation when it is trying to show the demo or something. That is pretty what I did, and yeah, it looks. I hope it looks good. um, what I was trying to build on the YouTube channel, it is my second brain. It is my knowledge base and plus my skills plus my tools. So it has 4 sectors. The first one is updating pipeline. So I grab some knowledge everywhere, every day from Reddit, from X, from YouTube, from my new AI conversations with probably GPT, probably Claude, probably some some tools of China. And then I ingest it automatically into my knowledge base. And then inside of my knowledge base, that is the whole foundation of my automation pipeline. It includes, of course, a lot of articles. That articles is with a bunch of data cleaning from all of my conversations with these AI tools. And also, there is knowledge graph that I have a little bit of small algorithm. I extract each concept from each of the articles that I extracted from each conversations and each knowledge pieces I got. And these the concepts points, they are actually having relationships. They're connecting together, and that it's a visualized knowledge graph inside of my personal knowledge base. Actually, it's built inside of Obsidian for my personal looking, but for large language model, it's for different. And I also have a AI dictionary that's full of the entity terms. That with the entity terms, then it helps to build the concept points so that I can build the knowledge graph. And also the AI dictionary entity terms, it's also like automatic, it's updating itself, and I also have it open source so that other people, if they like it, they can have a look at it and they will find a list, a whole bunch of AI words that they probably can learn. With this whole knowledge base, I do have a lot of skills. You can see over here, I call it a tools layer. I have content generation tool that basically helped me write my script of each of my video, and it imitates the way I speak, because I need to post in different languages. I post it on different countries' social media, so I need to do localization as well for different languages. I need to tell jokes inside of my video, so I need localization tools to help me automatically do that as well. And also, after writing the script, I used a local model that's called IndexTS2. That is also open source. Everyone can deploy it locally in your computer. You don't have to go to the online platform and give them your voices. You can hold it directly locally, yours on your computer, and it's totally free. And my GPU sucks, so I think nearly all of you can deploy it as well on your computer. And it actually imitates the voice of mine. I think it's doing it in a great job. You can see in the video, I don't see much difference between the way it speaks and the way I speak, except for it speaks better. And also for the editing, I use a framework called Remotion that is editing the video with code. So basically, your video after you've done the work, it is in code, so you can directly open it. It's static, and so the output of your large language model, whichever tool, Codex or Claude that you connect to, the outcome is stable. So it's yours. It's local. It's there. And if you want a preview, you can also run it on the Chrome, and you can see exactly how the video looks like. And the good thing about it is that it is very precise into each frame. So you can do very, very specific detailed editing of each frame, and it's very convenient. Also, I do some posting on LinkedIn and blog and SEO for my own computer. My own website. I posted like also automatic generation that is based on some are based on my script generation. That's the content generation skill that I have, and some are not. But I do have some other like automation content generation kind of skills, and the other one, the remote access layer, that is pretty, that is also 𝐿𝐻𝐿. Everyone likes 𝐿𝐻𝐿. I connected to my Discord. So if I am outside, I have no time to sit in front of my computer, I'll just text it on my Discord, like, hey, can you like have a look at my computer, and is this progress ended? How is it doing? And then probably let it. I also connected some simpler skills to 𝐿𝐻𝐿 because I don't want it to delete everything from my computer. So there are some basic skills connected to my 𝐿𝐻𝐿, so I can securely finish some of the tasks when I am not when I'm not at home, when I'm away. So this is the whole structure of the thing. Yeah, and this is the more detailed look of my skill. The knowledge and voice part. So knowledge, it is in the knowledge base. Yeah, and so there is a 4-stage pipeline from a 1-paragraph spec. And I first filter it and then summarize it and into glossary and export to Obsidian. That's my knowledge base. And then it's the TTS skill. That's what I said about the model that imitates my voice. So it is unlimited bilingual narration. So actually it speaks a lot of language, but I only speak 2 languages. So yeah, so I call it bilingual, but if you have more languages to speak, it's more than that. Oh, by the way, it's a 0-shot one, so I only give it like 1 piece of my voice, so it can directly do all of the imitations. I only give it like 2 minutes and 28 seconds of my voice. That is not very long, and it already does that bilingually. And for the background music, every video needs background music, or else it's gonna be so dry. I used a model called MusicGen, and a Claude code can write the prompt, and the prompt can generate the music, and the music fits the scenario that I wanted to fit. So actually, I only tried once, and then it already generates the perfect music I wanted to have inside of the video. I'm good with that. And then it is the video skill. As I mentioned a little bit before, it's with Remotion, and actually it's built with React. So everyone, if you are skilled with React, then you are skilled with Remotion. So yeah, it helped me with a 9,578 frames and 30 FPS in an MP4 file. It's pretty happy with that. So Claude Code helped me with this skill. It wrote the entire composition, captions, motion, everything in line, nothing wrong. I'm pretty happy with that one as well. So yeah. So after all, I think it is about harness engineering. Everything is about harness engineering as long as you use any AI tools. Writing code, as it says, writing code is the easy part, right? But the multiplier is to teach Claude Code to remember what you did, and then it can automatically what you do and do it again and again and again, probably when you're sleeping. So yeah. So like with a good harness engineering, then every new session, it starts with full context. For every time that you use this kind of AI agent, right? As long as you almost reach the limits of its context window, it will get a little bit stupid, you know. It's not going to be very precise. It's going to hallucinate a lot. So every time, probably when you reach the 80% of the context window, you probably want to either compact it, and then it will lose a lot of its memory and be dumb, or you just open a new window. But if you open a new window, it lost all the memory. So we have to store the context very carefully, very structurized into somewhere that it can find very quickly. So it is not going to lose memory every time, like in a K-drama, right? Yeah. So this is my tricks of how to work with Claude Code. AI is the last step. What does that mean? So the first step is probably digitalize it into the data. If you like probably hand drawing something, probably you like this kind of stuff. You firstly have to digitalize it and then into structured data. And then we have human in the loop, probably to look at the data to make sure it works. And then we have automation, right? We have to first make our workflow very clear to make it do it again and again, or else it's gonna just repeat the mistake inside of our workflow, and it's gonna make your whole thing not working. So skipping the front of the chain and the AI has nothing to stand on, that's going to be a disaster. So we have to make the front very clear. And then you have lived experience, AI doesn't. What does that mean? So like it can validate facts on the internet, but it can't validate life. But we have the advantage, we actually live. So probably there are something that we know that it doesn't know. So we have to keep our needs at the center of it all. Like it needs to listen to us instead of us listening to it. We have to make sure what is our needs. And be precise. Claude Code is German. That's a joke. I'm speaking like Claude Code is as a precise person, a responsible person is a German, but only if you tell it exactly what you mean, right? If you give it a very vague brief, then you get a very confident wrong answer, right? It's not going to guess what you're thinking in your brain. So better be clear, better be precise, better be specific. And then be humble, listen to the trade-offs. So what I said before, trusting your living experience, be very precise, be very specific. It doesn't mean that we don't listen to AI at all. So when we are building, because before we use it, we have to build it, right? When we are building, our goal, of course, it stays, but our architecture might need update. We have to probably have discussion with the AI all the time when we are building to make sure our tech stack, it really works and it works for a long time. Don't stuck on yesterday's design. It means that, probably yesterday, I think it's pretty good already, but today, I think probably there's a better tech stack, but I don't want to try. That's not good. We always, when we are building, when we have choices, we always look into the trade-offs to choose the better one for us to build a long-term kind of workflow. And explore while building and exploit after shipping. What does that mean? So we were saying that when we're building, we try with a lot of different options and consider about the trade-offs. So like we try everything when we're developing, but once it ships, it's good to not change it, right? As long after it's shipped, as long as we are working with it, we don't want to change a framework every day. That it's very time consuming and it's making our production not very stable. So yeah, robustness beats novelty, right? And that's all. Come and find me. This is my YouTube, this is my LinkedIn, and the whole slides are all built with Claude Code. And this is another skill of mine. If you want it, probably I will share it later on my YouTube. Yeah. Thank you.
Awesome. Any questions? I'm kind of like, I feel like I'm so behind. I never find any of the skills, that's all. Yeah.
Hi, very insightful presentation. I think I really love the slides as well. It was very cohesive and very coherent, very lucid. I just want to know from your video making experience, I know like when you are building a 6-minute video, 7-minute video, there might be some small changes that you might want to do when the video has been built end to end, so you might not like one of the sentences that it might have spoken, or you might not like the placement of the speech bubble or something like that. So how do you really correct those small elements? Do you prompt it, and ask it to render the entire video from scratch end to end? And just can you walk us through this?
I think this is a pretty good question. I will show this graph again. So when I am building the video, like firstly, it's the script, right? Inside of the script, it already tells each line what I want to speak. Each line. If I after every node, there is a human in the loop. So I personally I like human in the loop a lot because I like to take initials and I want control. So after every node, there is a human in the loop. So for example, after the script is generated and there are my lines, and then I don't like it, I'll just change it. And inside of the script, there is a part that shows, oh, here is a demo of me doing something. There will be a placeholder. So if I don't like that, I'll just delete it. Or if I don't like it, I will add something more. And also after the voice is generated, there are I also made it into two options. There are every sentence. So I like chunking, so I make it into chunking. So for every sentence where you can say chunk, it is separated, and then later on it's combined together based on my needs. So if there is a sentence I don't like its tone, I don't like its emotion, I think it is speaking too sadly, then I will directly change it. Saying I just change the parameter, because based on the parameter, it changes the emotion. So yeah, and then it's the motion editing. So it is like the video editing. So it's purely code based. As long as you change the code, the video directly change. So before you render it, of course you can see it. You can preview it, and then as long as you see it, you don't like it, then you change the code and it directly changed.
Is there any, I would say, do you create like for the prompt, you have prompt templates, or do you have some YAML file or this kind of thing? How do you do it?
Yes. So this is all skill based. I all wrote it inside of Claude Skill, so it's all like inside of Claude Skills. When I talk to it, it already knows what to do.
Any other questions? So excited. Let's do the test. All right, let's give her another round of applause. Thanks. Let me just quickly to show you. So if you go to our webpage or you scan the QR code, you can find that this is our link. If you click the 200,000 plus followers, and then you can find a link tree. Okay, on the top, you should be able to find the photos. Okay, so you can upload your photos as well. You can download or upload. We're using Google Photos. I already took some photos. I already uploaded. Yeah, please you can save the photo, do some LinkedIn post to help us spread the news. We are hoping to keep this community running, okay, to potentially find more relevant speakers and also find a sponsor to support us the food drinks. Tonight, actually, I'm paying the food drinks, okay? You don't want me to pay every month, all right? We need your help to help us spread the news, okay? Okay, back to the one. Oh, I forgot to mention one thing. Here we go. Yeah, you might be interested to join one of the event here, same place. So we will share you the slides. If you want to scan the QR code, it's like a finding job. It's a job related. If you're looking for a job or just join the events, you can scan the QR code to find more information. And you need to register first because limited seats. It looks like they only have like 30 seats available.
And Steve, they actually for people who want to apply for applied scientist roles.
Okay.
AWS. So if you have like a PhD, that's where they like to target.
Okay, okay. Yeah, did you guys hear? Yeah, you scan the QR code, you should be able to find all the details.
Sorry?
PhD.
Look, it is actually trying to it is actually targeting anyone who is actually trying to apply for a job as an applied scientist at AWS. That's what I was told. It's saying that calling all applied science PhD students. I think that's the core stuff. Sorry if you're having PhD. I don't have these.
All right, let's continue. So are you guys ready? So we're using the Slido. Let me see. Yeah, I always forgot.
I'll be.
All right.
Next one.
Yes, the next one. So I'm going to activate now. Now you should be able to scan the QR code and then we will answer 12 questions. So start where? Where is the QR code? Okay. Oh, come on. Here. Oh, I always forgot where is a QR code. Yeah. Now it should be here. All right. Yeah, we got a few people already join. Come on, did I share my screen? Let me see.
Will it work with Safari browser?
Okay. I think it should work for any browser.
Because earlier I had problem with Safari or with Chrome.
Oh, so why not download a Chrome? Okay. All right, looks like we got a 24 people. Anyone still in progress? Are we all good? Ready? Ready to go. Let's go. So is that next? First question. What is the primary purpose of Amazon EKS hybrid nodes? Can make it a full screen. Yeah, by the way, online attendees, you can join, but except digital swags. Okay, we can't ship the physical, swags. So the first one, oh, you guys are awesome. Oh, everyone getting it correct. Yeah. Next question. So which model was selected for the demo in this presentation for its VLM multimodal capability and the low latency performance? Very good. 92% correct. Next question, which AWS service is used to collect GPU metrics such as temperature, power utilization from on-premises EKS hybrid nodes? Yeah, the correct answer is which one? I don't know which one is the correct one. I can't remember. Is that C or D? C, that's C. Main service for Prometheus. So next question, according to the presentation, what is the key business driver for adopting a hybrid AI architecture? Yeah, we've got 4 options. Yeah, let's see. We've got 87. Okay, next question. Yeah, we are pretty late. Let's move on quickly. Who is Peter Steinberg? If you don't know, just do a guess. All right. So 79% answered correctly. Okay. Next one, according to the talk, how does the complexity of 70,000 lines of application code compare to 70,000 lines of AML? Okay, this one is hard, right? We got a 64% correct. Next one, what should you do when an AI model fails to build a feature? All right. Build smaller building blocks is the correct answer. So we've got a few more questions. When was the Open Agent Skills standard officially published? Yeah, AI world, everything is new, changing so fast. Shouldn't be 2024. So it was December 2025. In the automated video content creating pipeline of Ava, which tool was used to render the final episode 1 video? Yeah, this one is harder. Oh, good. You guys are awesome. 70% correct. We got a few more questions. Only 2 questions, actually. Ava used the index TTS2 for voice cloning. How much of her own voice recording was needed to generate unlimited bilingual narration? Correct answer, 2 minutes, 28 seconds. Which file is suggested to give Claude Code persistent project-wide instructions? So every new session starts with a full context. Yeah, this one should be easier, right? Even you never tried, you can guess. Guess it correct. Yeah, good. 88%. Where is the suggested position AI fit in the person's workflow? By the way, this is the last question. You still have a chance to jump to the top if you answer correctly fast enough. So let's see who are the winners. So the correct answer, AI is the last step. Digitalize and structure your data first. Okay, let's see who are the winner. So the top 5, you got the choice, you got the options to select different price. In the bottom, you don't have any selections. Let me show you the swags first. Where is the list? First of all, who is David? Yeah, let me come back here. What price we have? So we should have something for you. My own collection. I got a book, and yeah, as I said, the bottom one, you need to join our Discord. Okay, for the 50% off or 100% off. Let me bring the books. Okay, I got a one bag. All of these are my own collection. Okay, seriously, yeah. So yeah, come over here. If you don't mind, we take a photo. Okay. So one of the conditions, you do LinkedIn post tag us. Okay, right. So I got the book. Are you learning Kubernetes?
Yeah, just
If you're learning Kubernetes, the book is pretty good. Yeah. Otherwise, we got some tissue here, but M size, all M size. Yeah. So
actually choose one or
yeah, you can choose any one of these, except the bottom. You need to join the Discord. Except the bottom, the 50% off or 100% off. That one you need to join our Discord. Yeah, it's someone donated. Yeah. Okay. Otherwise, feel free to choose a t-shirt. Yeah, if you like. Yeah, grab whatever you like. And come over, taking a photo.
wait.
More you can open, yeah, to have a yeah. Let's do a photo. All right, congratulations. Yeah. Who is next? Where is it? Afros. Did I pronounce your name correctly?
Yeah.
Okay.
Actually, I answered all 12 correctly.
Oh,
But one
amazing.
question, because I got notification and because I pressed.
Okay. Yeah, what would you like? Yeah, I don't really have anything else. Yeah, that over here. The t-shirt or M size?
Yeah. All M size.
Or M size, yeah, because that's I went to a conference, I collected.
This logo is for what?
That's a con.
Yeah, I will take.
Okay,
This is
okay.
Excel, sorry. It's really big for me.
Oh, is that Excel? Oh,
Yeah.
I didn't realize. Yeah, otherwise M size. I believe most of these are M size. Yeah. Let me see. Yeah, also you can have a Claude code
Yeah,
sticker.
I will take this. Yeah.
Okay, yeah, let's do a photo. Do you want a Claude code sticker? Yeah, it's not expensive, but it's pretty costly for me to travel far away.
Is
bring
it?
back. Yeah, I went to Google Cloud next. I bring it back. All right, thanks. Congratulations. Who is next? Olga. Huh? It's all right. Yeah, come over. Yeah, at least we take a photo. Take a photo. Yeah, yeah. Come have a look.
Hey, we connected on LinkedIn
Oh.
recently. I'm Lang. Nice to
Oh,
meet you.
awesome. Yeah.
Oh,
That's all we have here. And you can take a sticker anyway. Or maybe two, if you like, two different one. Oh, the book?
the book has the
Yeah, the
price?
book, yeah, it's pretty good, yeah.
Oh, I'll take the book.
Okay.
Thank you so
Yeah.
much.
Do you want we take a photo? Maybe move this side. We capture our logo. Awesome.
Oh,
Thank you.
so much.
Congratulations. The next one, Yash. Oh no, is that oh that's Georgia. Okay. Who is Georgia?
Oh, I'm here. I'm here.
Yeah, yes. Who is Georgia?
The one you gave the book.
Oh, pass to me.
Okay, so both of you are winners. Okay. Do you want to take one more stuff? Yeah. It's all right if you are interested. Yeah. Otherwise, Yash,
Yeah.
have a look. You can take a sticker as well. Sure. That's a limited edition.
Thank you. Is there any?
I think most of these are M size. Yeah, I'm pretty sure M size. Okay. Yeah, looks really good. Yeah.
Yeah.
Let's do a photo then. Awesome.
Thank you.
Who else? I don't know. Where is the leaderboard? Yeah, we should be able to find the. Let me see. Who is number 6? Where is the one leaderboard? Okay, here we go. Sumi. Congratulations. Yeah, we still got some stuff here. Come over, have a look. So you got 2 stickers and plus one of these if you want to choose. Yeah.
No.
Yeah, I don't have any other books. So this is just a notebook. Yeah. If you want. Yeah.
That is all then.
Okay. OM, yeah. Let's do a photo.
All right. Thank you so much.
Yeah. Next one. Is that Subam? Is that someone online? Oh, already left? Did I pronounce it correctly? Number 7, Subam. Nobody here? Okay. That's him?
Yeah.
Okay, we can get you digital swags. Okay. So that's all good. Yeah, you pin me by message. And then Senya. Next one, Senya. Congratulations. So I don't know if you like the t-shirt, yeah, but you can have the stickers or the notebook.
I like the notebook.
Okay. So we got a notebook and the stickers as well. Okay. Yeah. Okay. Yeah, okay. Do a photo. Come on. Yeah. Congratulations.
Thanks.
So next one, Siva. Who is Siva? Is that online as well? Okay, Siva is not here. Cereal. Okay, Cereal also, yeah, we can get you some digital swags. Okay, Cereal. Yeah, Cereal is a guy from Singapore, I remember, yeah. Who is next? DK. Who is DK? Congratulations. Okay, we got stickers and we got 2 tissue left. I don't know if you like. Yeah, you can have a look.
We should.
Yeah, T-shirt, yeah, I believe that's M size. Yeah, have a look. I believe that's that one probably big. Oh, that's XL.
Yeah, I'll go with this.
Okay. And if you like, from the Claude code secrets. All right, let's do a photo. Awesome. Congratulations. The last one, last prize. Who is 𝐼𝐂𝐘? 𝐼𝐂𝐘? No? Tilina? No? Taran? No? Van? Eric? So all online? Gordon? Yeah, one t-shirt for you, yeah. He's our newest volunteer. Yeah, we will do a photo selfie. I think that's all. Oh yeah, let's do now. All right, come over. All right. Thanks everybody. We still have some stickers left. Yeah, if you want, yeah, feel free to come over to grab one. And if you guys don't mind, let's do a group photo as well. Okay. Well, thank you, everyone. Yeah, come over this side. I will do a group photo and then do a selfie. Awesome. Thank you. Thank you, everyone. And our next one, third of you. Please join us next month as well.